I'm Emily Hummel.
And I'm Lucy Mervar, and today we will be demonstrating the experiment for disappearing blue.
Today for our experiment we're going to be using the 500 milliliter Florence flask, and it has a stopper to fit. We'll also be using 300 milliliters of distilled water, 8 grams of potassium hydroxide, and 10 grams of dextrose. And we'd already had them pre-measured out, so we're good to go. And we're going to use 6 to 8 drops of methylene blue.
This experiment suggested that we use 6 to 8 drops, so we decided to go right in the middle and use 7.
First, we're going to dissolve potassium hydroxide with the 300 milliliters of water.
Since we're dealing with potassium hydroxide, we decided to wear gloves for safety. And notice we poured the potassium hydroxide in first, and then we're going to add the liquid second.
The potassium hydroxide is very corrosive. Oh my god. Just spill the water everywhere.
Once this completely dissolves, we're going to add the 10 grams of dextrose.
Yay, dissolving potassium hydroxide.
You want to make sure it's all the way dissolved to make sure the experiment works good.
Okay. Here you go.
Now we're adding the 10 grams of dextrose. And we're going to put the stopper on top just to make sure that it all comes.
Once this is completely dissolved, we'll add the methylene blue indicator to shake it up, and after you shake it up, you'll need to let the solution sit for at least a minute for it to turn colorless. And again, we're adding 7 drops.
Normally you would let this sit for a minute after swirling it, but for time's sake we made a pre-made solution of this. And so as you can see, once you start shaking it up, it starts to turn blue. Or has it. Once you shake or swirl the flask, the blue will reappear and disappear. Once you stop shaking it, it'll turn back to its normal state of clear, colorless solution. This will continue to happen until all the oxygen in the flask is gone. This happens due to the oxidation of the methylene blue and the dextrose. When it's reduced, it turns colorless, and when it's oxidized, it turns blue.
The colorless reduced methylene blue plus oxygen turns the blue-colored oxidized methylene turns into the blue-colored oxidized methylene blue. The dextrose reduces the methylene blue when it's added. A reduction occurs when the oxygen is removed from the substance. In this case, the substance is the methylene blue. When the flask is shaken, it causes the methylene blue to oxidize. Oxidation occurs when when it adds to the substance, again, the methylene blue.
This first equation represents the solution when it begins at its blue state, so when we first added the methylene. And it starts here, the methylene is oxidized, so it turns blue. After adding the dextrose and the potassium hydroxide and shaking it up, it adds oxygen, and once it sits after that, then it turns back to its colorless solution after shaking it up and letting it sit.
The second equation that Lucy is writing represents the methylene blue when it begins at its colorless state. Once we begin to shake the flask, we are adding the oxygen, causing the solution to return to its original blue state. It will continue to return to the blue state until all the oxygen in the flask is gone. And as you can see over here, after letting it sit, it's now a colorless liquid.
That's the second equation that she just explained. There are many real-life applications of using methylene blue, and according to Mayo Clinic, one of the most important is used in surgeries. In surgeries, they use methylene blue to dye certain parts of the body before they undergo surgeries.
Another application is it can be used to treat a condition called methemoglobinemia, which is when the body can't deliver oxygen throughout the blood to certain parts of the body. And then these are our references. Okay.